So software-defined WAN is a transport agnostic approach. Meaning what? We are no more dependent on MPLS or IP or LTE, cell phone, cellular, 5G. You are no more dependent on those limitations, right? See, usually there is a lot of limitations. For example, I'll just give you one simple example in LAN. In LAN, when we have multiple connection, we have limitation with STP, spanning tree protocol. What is that? You cannot load share, only one active path. Likewise, there are limitations in MPLS. There are limitations in IP routing. MPLS is label switching, IP routing, 5G connections, LTE, the cellular connections. In all this, there is limitation. Now, if you are designing a topology using physical network, you need to understand the limitation and work according to the limitation. Work accordingly. But what SDWAN provides is a virtual topology which can be designed according to your own desire. As a result, you can have communication without any limitations. But when you use SD-WAN, if path option via MPLS is not fine, it will automatically establish the tunnel via IP path or some other paths that are available. End of the day, your tunnel will provide you the service without stopping. Your tunnel will provide the service non-stop. Your service will not be stopped because one of the WAN link fails. This is one big advantage of software-defined WAN. Only software can do those things. We human beings, if we need to do things in a very hard way. We need to write some coding, something like that. That's what already they have written and given you as a software-defined solution. So what I'm trying to say is, normal WAN technology, we all know. We know segment routing, we know MPLS, traffic engineering, MPLS, IP, internet. We may know 5G. You may know many things. But if you have MPLS traffic engineering, within the traffic engineering limit, you can do switch over. That will be with respect to MPLS. You cannot come out of it when there is a problem in MPLS. You cannot come out of it and try to take a IP path. Not possible. But when you do a SD-WAN integration and say, I don't care what path you take, whether you take MPLS or IPsec or whatever, I want the reachability. If that will be your configuration, if that will be your what to say, if that will be your policy, SD-WAN is very, very good for that. SD-WAN can work along with all the technology and find the best path to establish tunnel for you to reach the remote site. The best path to establish tunnel. That's one of the options. The other option is you can say, no, I want to establish tunnel only via MPLS for these traffics. For the rest of the traffics, I want to route it via IP. That is also an option there in SD-WAN. But one point which I am trying to emphasize here is this word, transport agnostic. That's one of the very big advantage of MPLS. Transport agnostic. This is what I was explaining you for this many minutes. Tunnels are established over an underlay, treating MPLS, internet, all as equal. Right? Only these things are possible through controllers. And SD-WAN provides those controllers. So we have few more advantages of using SD-WAN. We are going to see one by one now. What is the difference between the traditional MPLS WAN and the SD-WAN? Traditional MPLS WAN, you will use only MPLS. You will map the traffic statically to the MPLS tunnel, and any traffic that is mapped to the tunnel will be going through that MPLS tunnel. So configurations are manual. We have to go to every device and do the configuration, necessary configuration. Say for example, if you are doing RSVP, you have to go to every router in the path and tell, I want MPLS, I want RSVP, and this is the bandwidth for RSVP. We have to do those things manually. And it is not much application aware, meaning MPLS cannot differentiate between YouTube and Facebook. MPLS cannot differentiate between applications. It's not application aware. You can do some ACL, some protocol match in the QoS, some applications like Telnet, SSH. Only that much you can do quality of service. Only that much application awareness you will see. Alright, so application awareness, none. Provisioning. In order to establish a MPLS traditional WAN, you all work in the production department, production in the real world. You know how many months it takes to bring one WAN, MPLS traditional WAN network. From ISP side, if you see, it will take many days and sometimes months. Depends on how big the ISP and there are a lot of things that are involved in that. Government side, company side, policies. Now, if you take SD-WAN, as I just now told you, it is transport agnostic. Hybrid WAN, not just only one MPLS. It can work with the broadband, MPLS, LTE, 5G, all. And we are not going to go every single device to configure. We have a centralized policy configured in a controller called vManage, and from there we automate it. And now this supports full software as an application service. All those cloud visibility you get because you have the application visibility. And few days you will be able to have one site ready because you have zero touch provisioning option. What is zero touch provisioning option? Things get deployed automatically when you connect to the internet. When you connect to the internet and when you connect to the DHCP server, from the DHCP server, your new device, your new WAN edge device gets the IP address and the DNS address so that it can reach the head office where you have vBond, which is an orchestrator, and also it can talk to Cisco Cloud and get it registered with your SD-WAN controllers. So zero touch provisioning is a very big reason why SD-WAN can be deployed in a very short duration. All right, so in business we want that. We want that fast deployment, and then we want a tool where you can also monitor in a centralized single pane of glass. And we also want, sometime for some traffic we want direct internet access. For some traffic you want to go via MPLS. So we have these things all in business requirement. That's why we need to go for SDWAN. SDWAN can fulfill all these things using one tool. Now this SDWAN architecture has got this four plane. As usual, we have one control plane and one data plane. Data plane is the place where the packet forwarding happens according to the policy given by control plane. So you have a control plane. Every router has got control plane. SDWAN device also got control plane. You also got data plane. Every device have got data plane. Every router switch have got data plane. The port interface, the MAC address learning, the fib table, the adjacency table, all these are data plane. So even here you got it. Now what is the difference? This control plane is automatically built based on what you put it in the management plane. So we don't directly deal with the control plane. We put all the configurations necessary, all the policy related configurations, including monitoring, software upgrade, all these are supported in this one control plane called vManage. So based on what you have configured, the vSmart will analyze your network and act as a brain to push the necessary configurations to all the edge devices. So the control plane is a separate controller. It is not one single box. This is a VM. This is another VM. This is another VM. They're all VMs. So these things are in a server. Whatever you configure on vManage for sites, you have various sites, as you site 1, site 2, site 3. You write policy, site 1 can talk to site 3. Fine. Then vSmart will collect the network of site 1 and site 3. Then it will push those routes from site 3. It will take routes and give it to site 1 so that in the routing table it will be available to reach. So the vSmart is responsible for the data plane, the edge device, path selection, and path forwarding. You don't configure anything directly on the vEdge. In all the sites, the vEdges are auto-configured by the vSmart, which is there somewhere in the cloud. It can be in the cloud or it can be in a remote site, head office. The vSmart only going to do the judgment of what all route that this particular site router should have. What are the routes that need to be filtered? What all we should give, what all we should not give. All those things are decided by vSmart according to the configuration that we do it on vManage. Now, what is the use of the orchestration plane? Orchestration plane is to orchestrate. See, let's say SDWAN is like a song, SONG song part. When someone is singing, there will be an orchestrator. We'll have one kuchi in the hand. According to the movement of the kuchi, sometime violin will come, sometime tabla will come, sometime keyboard will come, and these all put together form one song. Likewise, for any edge device to become a part of your SDWAN song, to become a part of that song, if the tabla need to be added, orchestrator should take his kuchi and he should show. Only then that music will join to the song. Likewise, A new site is coming and you got a VH. When this new VH comes, who authenticates and make him as a member of the SDWAN? It is this V bond. See, that's why the word bonding, bond. V bond. Yeah. So V bond is there to authenticate newcomers. V bond is to authenticate the data plane and the control plane and the management plane members. See, this is the first point of contact that authenticates the controllers and the edge device. So it's not only authenticating the edge device, the controllers. You may have multiple vSmarts. You may have another vBond also. Yeah, you can have more than one vBond. You can have more than one vSmart. So to authenticate, vBond is needed. Now, how vBond knows that? How vBond knows that this is our VANEDGE, VH device? Yes, this device comes with a chip. Inside the chip, it will have all the necessary information to prove that I'm a genuine member. We call it a certificate, digital certificate. So vBond also knows that anyone coming with this certificate is genuine. How vBond knows? vBond knows through vManage. So when you buy, your vManage will have all the necessary information. If you buy a new edge device, they will give you what to put inside vManage. When you put that, automatically it gets downloaded to vBond, and your new edge device can be now authenticated through vBond. Once the new device is authenticated, the new device will now know the location of the control plane and management plane through this vBond. I repeat, once the VANEDGE get authenticated, after that only VANEDGE will know the location of vSmart and vManage through vBond. So vBond will provide the information saying this is the IP address of vManage. You can go and talk there. Right? So this is the SDWAN architecture, which has got 4 components. This first 3 are VMs. vEdge is a hardware, but there is also Cisco Edge 1000V software version of data plane. Any question?
No, sir.
No. When you keep it in cloud, universally from anywhere, your company edge device can come and get registered. So vManage is a software, VM deployed in ESXi or any cloud service. It's a centralized network management system, and it's a GUI. You can access through HTTPS. vSmart, as I said, it's a brain. It's a control plane controller. That is also VM. vBond is also VM. This is responsible for authentication. Even if you have NAT, no problem. NAT traversal will happen. It will use UDP 4500, 4500, 4500 port number to do NAT traversal. So these 3 are controllers. The data plane is Either you can have V edge or C edge or both. C edge is Cisco's 8000, ISR 4K, ASR 1K. These are all new product in Cisco. Whereas V is a WebTailer, the WebTailer company is no more. It's with Cisco now. That's why they call it this legacy now. WebTailer 100, 1000, 200, 5000. Those means a lot. 5000 is really very big box compared to 2000. Right? So these are about the components in detail. Now, as I said, SD-WAN is a tunnel. The tunnel that uses this underlay, it can use MPLS transport agnostic. It's SD-WAN is an overlay tunnel which can use all this, which can work on top of all this. And for SD-WAN, there is a special routing protocol like BGP. Like BGP, we have a protocol called Overlay Management Protocol, OMP. OMP, like BGP. Alright, so we got the virtual overlay, you got the physical network underlay, and all the controllers, everything together, put together called SD-WAN fabric. Zero touch provisioning. I told you SD-WAN will take only few days to deploy because of this zero touch provisioning. Say for example, as soon as you turn on an edge device, give power and connect the cable. Through DHCP server, it gets an IP address and it gets the DNS server. So now what it will do, it will go to the vBond. By resolving the domain name, it knows the location of vBond now. Because all this vBond all connected to the cloud. So it goes to the vBond for authentication. And it has got a hardware chip in which all the certifications for validation is kept. With that, it goes to vBond. And vBond authenticates. Once the authentication is successful, it will show the location of vManage from where the configurations get downloaded. So without you configuring any route in the routing table, all the routes come into picture. This is what we call the zero touch provisioning. Any question?
No, sir. No.
So how the control plane comes up, meaning how a routing table automatically comes into a VH. See this VH, they go to vBond, they get authenticated, and then they know the location of vSmart and vManage. They get validated. After which, there is a special tunnel established. The tunnel is called DTLS and TLS tunnel between the vSmart and VH. Between the vSmart and VH. Using this tunnel, the vSmart will push all the necessary configurations that is needed for the WAN edge using a protocol called Overlay Management Protocol, OMP. That is how the data plane gets established. It's through the vSmart. The routes are learned. And then after that, using the route, you can form a tunnel to go to anywhere, to your remote branches. Very important page. Do you have any question?
Process.
The protocol OMP. As I said, this is a Cisco's protocol like BGP. Why I'm comparing this to BGP? See, like BGP, this has got a lot of attributes to carry, like T-log, service chaining information. A normal OSPF or EIGRP, they don't do those things. What is T-log? Transport locator. What is service chaining information? When you want to accept a traffic in your organization, you will have a policy saying traffic should go through the firewall. That is called service chaining. You say you go there, but before going, you go to firewall, get scanned. If firewall allows, you go. Go through IPS, go through firewall. That is called service informations. So all these are informations that are carried by this OMP, not simply the route or the routing table. Along with that, T-log, service information, etc. are carried. Alright, so this is the protocol that works between the vSmart and the VH, like a hub and spoke fashion. Who is the hub here? vSmart. Who are the spokes? VH. Alright, so they carry a lot of metadata like transport locator, VPN label, site ID, etc. Who? OMP. Right? So this provides the visibility for the sites. It ensures every site knows how to reach the other sites according to the active security policy. According to the policy only they will be allowed. Rest all will be filtered. Those things are taken care by OMP. OMP is providing routes according to the policy. What is transport locator? T-log. This is the one which helps to identify which path to take to go to the destination. To go to the destination is identified by site IP. Sorry, system IP in the site, remote site. This is like site IP, site identification. It's identifier of for a router in the remote site. Now to go there, which color I should choose? Should I go via MPLS color or public internet or LTE? Which color? Should I go with encryption or without encryption, simple GRE? All this info put in one folder called T-log. Based on the T-log guidelines, the packet will be forwarded. Is there any question so far?